Okay, so we're going to reverse the product rule. And before we do that, let's just review what the product rule says. So I'm going to use the u and v's. So we have two functions u and v, and in the fall, the deal was we took the derivative of the product of those two functions, u times v, and the result was the product rule, which says v u primed, but I'm going to write du dx today, plus uv primed, so u dv dx. Okay, so that's our product rule. Now I'm going to go take this and I'm just going to rearrange some terms a little bit here, because we're going to do basically undo what this rule says in the appropriate way. So I'm going to go ahead and subtract this v du term to the other side, and I'm just going to put those two terms on the right and then this term on the left. So it's going to look like this. U dv dx is equal to, and make sure you agree with what I'm about to write, because I don't want this to get too confusing here with all these symbols, the derivative of the product u times v minus v times du dx. Okay, so that's just this equation rewritten a different way. Okay, now we're going to integrate both sides with respect to x. And here's what that looks like here. Okay, we have an integral u dv dx, and we are going to treat these derivatives as fractions, and therefore dv and dx can be considered separate entities. So just take a look what I'm about to do here. If I have dv dx and I add the dx that has to be in the integral, these dx's can be seen to cancel. Okay, and that's how I'm going to treat it in this derivation and in this formula that we set up here. Okay, so I have the integral of u times the derivative of v, more or less. dv dx was there originally, so it is a derivative, and that's equal to, well, what happens when you do the integral of a derivative? Well, they cancel out. So what's left for this first part is just u times v. And then I still have to subtract the integral of v times du dx, but if there's dx over here, then that gets dropped just for lesser symbols to worry about here. And so this is a true equation. It doesn't look very friendly to us, but this is what we're going to use to undo the product rule. Okay, so I'm going to go ahead and highlight this. And this is the formula that you're going to want to remember for a technique that's called integration by parts, which is what it says up here. Okay, integration by parts. So what you have here is you're given an integral that looks like a product of two functions, u times dv. You're going to decide which part of the integrand is u and which part of the integrand is dv. Okay, that's going to be your choice, just like in u substitution, you chose who u was and then determined what the du that went with it was. Okay, so there'll be two parts here. You will set u equal to one of the parts, and you will set dv equal to the other part of your original problem. Then you're going to calculate these other four pieces, or the other two pieces that are missing. Okay, so if you have u, you can calculate du. We've done that before. And if you have dv, you can calculate v by integrating or taking an antiderivative. Okay, so this integral that you start with will be equal to u times v minus the integral of v du, and what you're hoping for is this integral is doable. And what I mean by doable is you can either use u substitution on it, or it's one of your basic patterns. Okay, so you're taking an integral that you couldn't do with substitution or your basic patterns, and you're transforming it into this expression, which you hope to be able to find an antiderivative for. What I would suggest is you're going to assign pieces u and dv in your original problem, and then compute this expression. And this is how I remembered it in high school. And you may not like this, but I'm just going to give it to you. Okay, so UV, well, that's ultraviolet, right? Ultraviolet rays. UV, that's ultraviolet, minus the integral. And if you say VDU really fast, it sounds like video. And that's honestly how I remembered it when I went through this course. Okay, so ultraviolet minus the integral of video. That's integration by parts, and that's the pieces that we're going to have to assign and the pieces that we're going to have to calculate in our integrals as we move forward here. Let's jump into some examples, and hopefully this process will make itself more clear as we get to some specifics. So here's an integral that we could not have done first semester. We have x times cosine x dx. Okay, we could try to u sub this. We'd run into lots of problems. It's not on our list. So it's a product, and so after I go through my first two techniques, I'm going to be thinking, okay, if it's not those two techniques and it's a product, then it may be integration by parts. Okay, so it's up to me now to assign two pieces in this integrand. One of these pieces has to be called u, and one of these pieces has to be called dv. I get to decide, and through some experience, you will be able to figure out who u needs to be and who dv needs to be. In the beginning, it's trial and error, just like it was with u substitution. Okay, so I'll just take you through, I guess, the correct way to do it. And you got to understand, you're not always going to get it correct the first time. Okay, so just because it's written in this order, maybe u is x, and maybe dv is cosine x dx. So now you got to figure out the other two pieces for the formula. So we need a du, so we get that by saying du dx is equal to 1, which means that du would come out to be 1 dx. And let's see here, if dv dx is cosine x, then that means v has to be sine x plus a constant. Now, the deal with the constant is it's going to come out in the end, so I'm not going to go ahead and write it at the moment. It does come out at the end as a plus c because we have an indefinite integral. Okay, so I have calculated the parts, and so now I just need to substitute them into the formula. So let's remember what the formula was. The integral I'm given is supposed to be equal to uv ultraviolet minus the integral of v du. Okay, so this original integral is equal to u times v, so x times sine x, minus the integral of v du. Well, let's see here. V is sine x, and du is 1 dx. And that's really nice, because check it out. I now have a integral that's on my list, one of my basic patterns. So all I need to do is do an antiderivative for sine x, and I'm done. Okay, so I've got x sine x minus the antiderivative of sine x is negative cosine x, and then I'll put the constant of integration here at the end. And now I'm finished. X sine x plus cosine x plus c. And if I want, I can do a real quick check to see if I'm right. If I take the derivative of my answer, I should end up with x cosine x, which is the original integrand here. So let's do a real quick check in our heads here, okay? Here's where the product rule happens. So this is going to be sine x times 1 plus x times cosine x. Sound good? And then the derivative of this is negative sine x. So that sine x that was here cancels the negative sine x here, and you're left with x cosine x. Obviously, the constant got wiped out. So there's a quick example of how this kind of presents itself to you. So at this point, check out your book, and you guys do 7.1, number 1. For your next example, here's a familiar guy as far as the function from FreeCal is concerned, arcsine x, but we have not been able to come up with an antiderivative for arcsine x. So this is one of our basic functions, but I don't know its antiderivative. So this is kind of cool. I get to finally figure out whose derivative is arcsine x and what the antiderivative for this guy is. So once again, you must assign pieces u and dv in the original problem, taking an undoable integral and trying to make it doable. Now, you're going to say to yourself, well, all I see here is arcsine x. So how can there be two pieces? And this now gets into, well, this symbol over here does mean something, right? That's why it has to be in all of our integrals, and it stood for something in the very beginning when we were doing rectangles. And that's very important here because that is my second piece. Okay, so 1 dx is the dv here. Okay, so du dx, the derivative of arcsine, jog your memories, it is 1 over the square root of 1 minus x squared. Okay, so if I have dv dx is 1, then that means that v has to be x. Technically x plus c, but we'll come back to that later. My du is going to be this times the dx. Okay, now you've calculated the 4 pieces, and hopefully this makes the problem a little bit nicer in the new integral that's going to arrive on the right side of the equal sign of integration by parts formula. Okay, so u times v. U times v. I have x times arc sine x minus, let me bump this down because I'm going to run out of room here. There we go. Minus the integral of v du. Well, let's see here. V is x, and du is 1 over the square root of 1 minus x squared. This is kind of the moment of truth when you do these parts problems. You're now saying, well, is the new integral that I've created any better than the original one? Have I done this correctly, or do I need to go back and try something else? Okay, so go back through your flowchart. Is this on my basic list? No, it's not. Is it a u sub? Well, I don't know until I try. My first instinct is to make u equal to, so now this is a different u than we started with, so keep your work organized here. U is the inside of the square root sign. That's my first instinct, which means du dx is going to be negative 2x. And that's good, because I have the x already there. I have the dx next to it. I just need to create a negative 2 in here. And we're able to do that because we're allowed to multiply an integral by 1 and not affect the value. So I would like it if there's a negative 2 in here. There you go. And that means I need to balance with a negative 1/2. So that becomes a plus. 1/2 comes out in front here. And now what do we have? We have x arc sine x plus, okay, what is this new integral going to be here? 1/2 integral du over root u, screw root u. And that's nice. I can do this one. It's on my list. And so we have x arc sine x plus, okay, you're going to have 2 times the square root of u. So the 2 and that 1/2 will cancel. So I have the square root of u, and what was u? 1 minus x squared plus c. Okay, that's not going to be one you memorize, most likely, but this is the antiderivative for arc sine x, as weird as it looks. Okay, pause the video. You now get to try 7.1, number 11. Just like you had to sometimes do the product rule more than once within a problem, or the chain rule more than once within a problem, you may have to do this technique more than once within a problem. So that is not necessarily a bad thing. You just have to take it easy and do things step by step. Okay. So again, we must assign the two parts u and dv, and u be t squared here, and dv be sine of t. And let's go ahead through the process here. The du will be 2t dt, and the v will be negative cosine of t. Okay, so this is for round 1, and so this integral becomes uv, well, let's see, what is that? That's negative t squared cosine t minus the integral of v du. Okay, well, v is negative cos, so I'm going to make this a plus sign now. And then the du is 2t. Okay, so 2t cosine of t. And you look at that integral and you say, well, wait a minute, that's not on my list, it's not a u sub, but it's another product. So parts are in order once again. So I got to do this process twice. Okay, no big deal, just keep going. Bring everything else down that's not going to be involved in the next round of u and dv substitution. And we're going to have to do this one more time, at least. Okay, so here's a plus sign. You are now doing integration by parts on this integral. Okay, so remember, that's going to be uv minus the integral of v du in a second here. So I just want to make sure I'm keeping track of all this. So this is now round 2. So if u is 2t and dv is cosine t dt, then that makes du 2 dt, and that makes v sine of t. All right, so now let's go back up here. Let's replace this highlighted integral with my formula. What's my formula? My formula is uv, so that's 2t sine of t minus the integral of v du. And let's see, v is sine t and du is 2 dt. So that's good because now I have an integral that I've done many times. And I have to use u substitution or parts. I'm ready to go. Okay, so it's very important to bring down your work, be very clear, especially when there's a minus sign in front of this second integral, because you may have to distribute that minus sign. The secret agent is going to be waiting to nail you in the ankle again. All right, so final answer here. Negative 2t squared cosine t plus 2t sine t. And then we have minus, but the antiderivative of sine is negative cos, so it's going to be a plus 2 cosine of t plus your constant. Wow. Can you imagine doing this 3 or 4 times in the same problem? They could ask you to do that. They don't usually. Usually 2 is the most. But you guys got to be patient and go through it if they do. All right, pause the video and give 7.1 number 7 a try. Check your answer with Bob. One is going to be a little bit interesting. It's kind of a special case, and you may have grown up with the song that has the lyrics, "This is the song that never ends." And it's not a very good song. It's kind of lame and annoying, but it kind of relates to this problem. If you're not careful, this problem could go on and on and on and on if you're not observant. Okay, so we're going to be observant here, and the key to being observant is what's the original problem. Okay, so I'm going to bump over a little bit here and do all my work over here so I don't lose sight of what the original problem was. In this case, it may not matter which one or which piece you assign to be u and which piece you assign to be dv. But let's just go ahead and do it this way. I'll make u sine x, and I'll make dv e to the x. In this case, we've got some nice pieces here. Du will be cosine x dx, and v, let me make sure that's doesn't look like a v there. There we go. V will be e to the x. And I should have included the dx with this piece right there. Okay, so this integral is going to be equal to uv, which is going to be e to the x sine x minus the integral of v du. Well, let's see here. V is e to the x and du is cosine x. All right, so again, you still have a product in here, right? And you're saying, well, I'm going to always have a product in here because these derivatives kind of just go in a cycle. And you're right, you do. But you got to be very observant and see what eventually happens here. It's kind of interesting. Okay, now we go to round 2. Okay, so round 2, we're going to look at this integral right here, highlight it so we're not distracted by the things. And I'll do my work in red over here. Okay, so what am I going to do now? Well, I made u the trig function the first time. That's not red. Let's try this again. Let's continue to make the trig function the u. Okay, and that would mean that the du will be negative sine x dx. Okay, the dv will still be e to the x dx, and that means the v is going to be e to the x. Okay, so now we're going to replace this integral. And remember, there's this minus sign out in front here. I can't forget about that, so I'm going to go ahead and put a giant set of parentheses right here. So I remind myself I have to distribute this negative sign to the two pieces here. Okay, so uv, what's that? That's e to the x cosine x, right? Yep. Minus the integral of v du. Well, v du is negative, so it becomes a plus e to the x sine x, v du. And now you're saying, hey, I'm kind of back to where I started. And you are sort of back to where you started, and that's a good thing. Look what happens here. E to the x sine x, let's distribute, okay, minus e to the x cosine x, okay, minus this integral is still there, right? Minus e to the x sine x dx. And look what you got. That integral is the negative of the original problem. And so what you want to do now is add this to the other side. And this gets you out of the problem instead of having to go on forever. Okay, so you add this to the other side, so that means you now have one apple, add another apple, you now have two of those apples. So you have two of those integrals. So we're kind of avoiding the issue here by doing it this way, but in this case it's the only way to go. So what's this equal to? It's equal to e to the x sine of x minus e to the x cosine x, and I suppose I should have the plus c on here somewhere, so let's put it here now. And then to get the answer, you just divide by 2. So your original problem, which was this, right? Integral e to the x sine x dx is going to be equal to 1/2, or this whole thing divided by 2, however you want to write it, 1/2 e to the x sine x minus e to the x cosine x plus the c. And the c can go inside or outside this quantity. It's up to you. Okay, I'll go ahead and put it outside because it's a constant. Multiplying it by 1/2 does not change the fact that it's a constant. Okay, so that's kind of the fourth scenario that pops up here. Okay, so practice is long as it never ends. 7.1, number 17.